Great. Well, thank you all for having me this evening. I appreciate also that you are not out birding, because at some level, I think that's probably what we should all be doing. Although I was very disappointed last night, I did a salamander / owl walk through Wildwood and only had the resident barred owl, none of the more interesting possibilities. So coming though, spring is coming. Yeah, so tonight I want to talk to you about shorebird migration and conservation in the Anthropocene. But I wanted to start out by way of giving a little sort of introduction about myself. So I claim Alaska, but I was not born there. And in fact, my first 8 years were mostly spent at Hawk Mountain Sanctuary in Pennsylvania, where I was indoctrinated, or not even indoctrinated. My father was a biologist, so I was born into this, and I was forced to go on long slogs up to the North Lookout, where I revolted by looking through the binoculars backwards. That is why I'm going to claim my rebellion may have peaked there, though, because here I am, a biologist as well. But my love of birds didn't really actually take hold until 8 when we moved to Alaska. And I was lucky enough to go to the Copper River Delta, which, if any of you know anything about shorebird migration, this is like the place. You can see flocks like this one of 500,000 or more western sandpipers in Dunlin. And what really captured my attention, though, as an 8-year-old, was the fact that a merlin buzzed over my head, went into a flock, and set off something like that. And that, for an 8-year-old boy, I think was pretty much a pure slice of heaven. So from the age of 8 on, I was really captivated by birds, and having a father who was a biologist, I was lucky enough that he had biologist friends, and they gave me this ultimatum at the age of 14, and they said, well, you can get a job bagging groceries, or you can go work for some biologists. So I was lucky enough to sort of go to all of those places and work for folks in remote quarters of Alaska throughout high school and college. But even then, I wouldn't have considered myself a scientist. I was really in it for the ticks. And my Alaska list was doing all right at that point. And along the way, I got to hold bristlecite curlews in the hand. But right about the end of high school, one of the people who I'd been working for, Bob Gill, published a paper that really blew my mind. And that paper had this title, which I think is a pretty fun one: Guts Don't Fly, Small Digestive Organs, Beast Bar-tailed Godwits, which may or may not tell you exactly what it's going to be about. Let's see. So what they found was that if you looked at bar-tailed Godwits that were preparing for migration in Alaska and compared them to sort of a normal bar-tailed Godwit, some expected things came out. All right, this is the relative size between a migratory bird and a sedentary bird of, for instance, their leg. So their leg doesn't change as they're preparing for migration. We all know that they put on a whole bunch of fat. But what we didn't know until that point was that these bar-tailed Godwits were shrinking the size of their digestive organs. They were doing away with them almost altogether, cutting down gizzard size by half, liver size, kidney size by 40%, all to prepare for this migration. Well, why might you do that? That was the captivating question at that point. And so that, I think, I can trace my sort of interest in being a scientist, that paper being published. And so then after I graduated from college, I knew what I wanted to do. And that was I wanted to continue to study shorebird migration. And so I wanted to take off on a mystery of my own, and I was able to get a research fellowship with the, I would say, sort of audacious goal of figuring out where Hudsonian Godwits, not bar-tailed Godwits, Hudsonian Godwits went during their southward migration after they left the Canadian and Alaskan Arctics and before they ended up at the southern tip of South America. And so that's what I did. I tried to do that. And those colors aren't so good. I set off hitchhiking and taking way too many overnight buses across South America, stopping in all those places, trying to figure out exactly where Hudsonian Godwits went. And the punchline is that really, well, I failed. I didn't figure out anything anybody didn't already know. And luckily, I didn't have to really return on this grant, or I might not be here still talking to you about science. But a very much more lucky thing happened the very year that I got back from that trip, which was that little devices like this one started to become available. This is a satellite transmitter. This particular one weighs 2 grams. 2 grams is about 2 paper clips. Well, you can see my thumbs there. Don't worry about how dirty the fingernails are. It's about this big, and it allows us to track the movements of birds in real time. So this particular device would give us about a location every hour for 8 hours of the day, then spend about 24 hours off, then turn back on. So these became available right after I got back. And the very first thing we learned with these miniaturized devices was what those bar-tailed godwits that became obese, but regressed their digestive organs, what they were doing. And maybe you all know this, but this is what a bar-tailed godwit breeding in Alaska does. It takes off from southwestern Alaska and goes on a 9-day nonstop jaunt to New Zealand. So that's why it had to bulk up all of that fat, but also do away with all those digestive organs, because it wasn't going to use those digestive organs for anything for the next 9 days. That would just be excess weight. We've since tracked one from up there, actually all the way to Tasmania, which was, I believe, a 12-day nonstop flight. So that first bird, 9 days, spend a couple of months in New Zealand, then on the way back north, only a 7-day jaunt up to the Yellow Sea in China, stuck there a couple of weeks, and then this measly little 5-day flight back to Alaska. Well, this really showed the possibilities and has then made me want to not only pursue the mysteries of migration, but then trying to figure out how these crazy flyers sort of link their migrations with the rest of their lives, what they do both on the ground and how what they do on the ground influences what they do in the air. And instead of bar-tailed godwits, I've kept up my focus on Hudsonian Godwits by and large, although I've spread out to some other species. And so my research uses these tracking devices and, as I said, tries to link them with what's happening on the ground. So we like to go and spend time with individual birds where we learn about things that influence their livelihoods, like resource abundance. We like to also be able to follow them while we're on the ground. So we use what are called mark recapture techniques. Then we can link this up with sort of broader environmental contextual information through remote sensing devices, satellite imagery. And then finally, we try to interface with lots of community scientists in the places where the birds we track spend their time so that we can develop estimates of population trends. And all of this is really, we hope, in service of shorebird conservation. So those Hudsonian Godwits, I continued to be captivated by them. And what started out as me lonely and hitchhiking across Patagonia in southern South America has now grown to be this really awesome transcontinental team that includes graduate students of mine over here on the left, and colleagues at USGS in Argentina and Chile, my wife Maria, who's also a professor at UMass and studying birds. And this really enables us to be wherever the birds are and hopefully learning something about them that we can interface with the people who also live in those places. So what does a Godwit's life look like? It's not just a huge migration. There's a lot more to it. And let's start with what does the life look like for this little guy. That's right out of an egg, maybe a couple of hours before I have it in my hand. And it's able to run away from the nest. If I hadn't held it right there, it was going to be on the move. And so Godwit chicks can venture up to 1 kilometer away from the nest within their first day of life. And they are surprisingly hard to catch given how small they appear to look. But life is not easy for them. Being a chick in the Arctic means that you have to hit things just right. If you're hatched too early or too late, you might not hit what happens in that blue square right there in the middle. And that is the peak of insect abundance. So shorebird young need invertebrates. And in the Arctic, those invertebrates are not available necessarily for very long. So that box happens to be 28 days, which is the amount of time that it takes a Godwit chick to move from hatching out of its egg to being able to fly away on its own. And you can see that on either side of that blue box, that there aren't many insects available. So if, as I said, if you're hatched too early or too late, you're probably not going to be very likely to make it. Because what you have to do is you have to be able to grow. And so we can see here the relationship between the likelihood that a chick survives on any given day, which is there on the vertical axis, and the amount of invertebrates on the horizontal axis. And there's a really strong relationship there between what we see in terms of invertebrates on the ground and the likelihood that a chick survives. And grow you must, because this is well, it's a little older than 28 days, but this is a very young juvenile godwit that's completely on its own. Mom and dad have gone, moved on, and it's now on the intertidal mudflats. And so it has gone from hatching at about 22 grams to this bird being probably 220 or so grams in a matter of maybe 6 weeks. And then after that, now this red isn't showing up very well either, you have about a month to get ready to launch on your first southbound migration without any of those adults around to necessarily show you the way. So 2 months in Alaska, then you're on your own flying south. And from Beluga, which is where we've been working for a long time, they first head to the central Canadian saline lakes in like Saskatchewan and Alberta. That's only 3,000 kilometer flight. From there, they then hop on over to the Amazon basin, spend a couple of days, head on to Buenos Aires, and then all of the godwits basically that breed in Alaska wind up on Chiloé Island in Chile. So you do all of that within the first 3 to 3.5 months of your life. That just sounds hard, right? And unfortunately, not that many make it, right? It's hard, and it's hard for a reason. But on the other end, what they finally wind up at in Chiloé, at the end of the rainbow, are small intertidal bays that hold really quite massive flocks of godwits. Not all in this picture, but this bay sort of on average has about 1,500 godwits each and every non-breeding season. But if life was always that hard, right, there probably wouldn't ever have evolved to be a godwit. So godwits can't necessarily have a hard life throughout adulthood, even if it might seem that way to us. So I just told you about this southbound journey. Of course, adults are making this as well, although they tend to do it ahead of those juveniles. What do they do on the way north? Well, it's maybe not quite the bar-tailed godwits venturing across the entirety of the Pacific, but they're making a pretty epic flight of their own from Chiloé Island to at least the rainwater basin of Nebraska. That's a 6 to 7 day flight, 10 or 11,000 kilometers. And what's actually, I like to lord this over the bar-tailed godwit biologists, is that the last 1,000 kilometers or so, right, they're flying over the land already. They're like, nah, I'm good. I don't need to stop here. I'm going where I want to go, which is for some reason, Nebraska. They spend a couple of weeks in Nebraska and the Dakotas and then do a 3-day flight back to breeding grounds in Alaska. So that's still pretty epic, but evidently for an adult godwit, it's nothing too much. So the average adult lives about 10 years. During that time, round trip, they're probably flying over 140,000 kilometers. That's just in migration distance. That doesn't take into account like, you know, the jaunts around the bog or the mud flats or whatever. But this is how many times they skip breeding and just stick around South America. None. They do that migration each and every year. I've literally yet to identify an adult who has skipped a breeding season and then come back subsequently afterwards. The other thing that's pretty crazy is that you might imagine, say, you fall a little behind schedule at the end of some breeding season. Maybe your chicks took a long time to grow, or you just were exhausted by the fact that you had chicks or something. And so maybe you depart Beluga a day later than you might otherwise want to. We see that what happens in terms of the timing of Godwit movements is that they might actually sort of become later and later on their way down to Chiloé. But then this magical thing happens in Chiloé where you could actually arrive as much as 2 months late to Chiloé and still leave to go north again the following spring, exactly on time. So Chiloé, at least when it's right, is a pretty magical place where they have really super abundant resources. And so if we look at the timing of those birds, after that period in Chiloé, they're, as I said, able to be on time and they can maintain that schedule back northwards. So this means Godwits aren't skipping breeding. They seem to be able to sort of rectify their schedules from year to year, build in some flexibility. And what we also see is if we look across shorebird species, you might think, oh, those birds that are flying the longest distance probably don't live that long because it's so hard. But that's not at all what we see. So on the horizontal axis here is maximum one-way migration distance. And on the vertical axis is the average survival of adult birds. We really don't see any relationship right there between migration distance and survival. So this is definitely something that these birds are evolved to do and is not quite as hard as we might perceive it to be as sort of ground-based humans. All right, so then after this, might lead to the question, well, is life always easy for the adult Godwits? And alas, the answer is no, not necessarily. If we look at the population trends of long-distance migratory shorebirds as a whole, over the past 4 to 5 decades, they have declined by over 50%. This is across 18 species of long-distance migratory shorebirds. If we look at just Hudsonian Godwits, it's estimated that their Atlantic coast population, what used to stop on Cape Cod, has declined by about 98%. Now, I don't actually believe that number because if you go down to South America, there are still substantial numbers. But let's suffice it to say that the trends are not looking good. So why is that happening? Well, my pitch to you is that there's no one, silver bullet, it's the wrong, there's no one answer for why it's all going south. Instead, there are myriad simultaneous changes that are occurring everywhere along the migratory routes that these birds follow. So if we take those Godwits that are nesting in South Central Alaska, well, the first thing that everybody often thinks about is climate change. And in fact, that is occurring. So this graph here shows April and May temperatures. So they tend to arrive in South Central Alaska at the end of April. May is when they're laying their eggs. And they've been warming at about 1 degree Celsius per decade over the past 4 decades. So that means that shift, that peak insect abundance, that first graph I showed you, that's shifting earlier, and it's about 9 days earlier than it used to be, precisely because of climate change. Once they leave Alaska and they head on, say, to the Amazon basin, well, we know that there have been massive rates of deforestation that are changing the hydrology and the availability of the low water side channels that Godwits make use of when they stop over there. We look at that magical place, Chiloé Island. Well, many of those small intertidal areas are now dotted by aquaculture practices. There's actually 3 different kinds of aquaculture that you can see in this photo here. And what that leads to is increased disturbance in these intertidal areas. Then back on the move through North America, just in the period between 1998 and 2013, wetlands and other natural habitats were converted to agricultural lands at a rate of 5.4% per year in the Dakotas and Minnesota. That was the most rapid change since the very beginning of the 20th century. So things are happening everywhere that Godwits are touching down. How do these actually affect Godwits then? Let's take a look at Chiloé. What we have here is on the horizontal axis, a index, a measure of habitat quality. And on the vertical axis, we have the body condition of individual Godwits that were observed over and over again using different bays. In those bays where there's more aquaculture, there's more disturbance, the birds spend less time actually foraging, more time alert, agitated, and flying because they've been disturbed. And so they have a lower body condition. If we then fast forward to Alaska and look at the birds that are actually returning to the breeding grounds, their body condition on the non-breeding grounds on Chiloé was substantially higher than that of birds that didn't successfully return. So that means the birds that are using bays with more disturbance are far less likely to actually survive their northward migration. Part of that is because what's happening in between is that Godwits are predominantly now using agricultural wetlands. And we see in this graph, the proportion of the stopover sites that they use, the kinds of habitats that they fell into. You can see that almost 50% of Godwits are stopping over in row crop agriculture, another 20 and 15% in managed grasslands and pastures. So by and large, human modified landscapes. And so in years when there's not much water, farmers do their best to get rid of water where they can so that they can plant. We see really dramatic influences on the survival of adult Godwits. So that horizontal axis there is anomaly, the amount of precipitation falling in the Dakotas. On the horizontal, or the vertical axis is again that adult survival. You see a 20% difference between the driest years on the left and the wettest years on the right. Godwits are supposedly long-lived birds, so if you start inducing a lot of variation in survival of the adults, that does very, very, very bad things for their population. And that's what we see if we look at trends in adult survival over time in Godwits based in Alaska. We see that over the past decade or so, it has declined. And thus, in turn, we see that the number of nests that are actually initiated in our study site in Alaska has fallen about by half. And what is more, if we look at community scientists collected data from across Chile between 2014 and 2019, we see evidence of about a 40% decline in those counts there. So there's my downer of an ending to the Godwit story. Now is hopefully a bit of a pick me back up. So signs of resilience. One thing that migratory birds predicate their lives on is their ability to be flexible. They're going to all of these different places. They're making use of tons of different kinds of habitats. And so if we can identify the sort of axes along which they are most flexible, we might be able to manage appropriately for them. So one of the really cool things that one of my PhD students, Julian Garcia Walter, who is from Northwest Mexico and works on red knots, actually in Northwest Mexico, not Hudsonian Godwits. What Julian has been doing is he's been setting up a network of Modus towers. There's a Modus tower on the UMass campus. Does Hampshire Bird Club have anything to do with the Modus towers? Are you familiar with this? Okay, Modus towers are an array of sort of automated receiving stations that if you put little tracking devices on birds, they send out signals every now and then. Modus towers collect that information, and so they sort of passively are monitoring birds that migrate past. Something to look into. Lots of bird clubs across the country are sponsoring their own Modus tower. Anyway, Julian's been setting them up all across Baja California and the Sinaloan and Sonoran coastlines. And he's using them to track knots. And the not so picking up part of this is that he's projected that if we look at the effects of sea level rise and habitats that red knots use, by 2050, he expects there to be 35% less habitat and the remaining habitat to have decreased in quality by about 25%. Now here comes hopefully the pick me up part. One of the big things that his modeling has projected is going to be lost is the habitat that red knots use at high tide to roost. Until he saw this, you may not be able to tell, this is sort of an ugly picture, but that is a floating mass of seaweed. And apparently, when there are really high tides, what the knots actually do is they aggregate on top of these floating masses. And these masses actually are just moving along the shoreline. So we think that this is the kind of thing that, hey, we know how to build floating mats of stuff. Are birds going to be able to find it? Are they in predictable places every day? Can we, just put them in random places? Well, what he luckily had done is he had put tracking devices on these knots. And so he was able to see in the left-hand side here how they go out and actually scout where these floating masses are and make use of them. So the yellow tracks are their days on non-big high tides, and that blue track is the day of the first spring tide of the month when there was really high tide. And it found one of those floating masses. And you can see here on the right, this is sort of the tidal cycle. Each of those numbers is a point on that map, which is unfortunately a little small for you to see. But it spent that period of the highest tide on a map that it had found floating right along the shoreline. So Julian is now working with some of his local partners in Northwest Mexico to explore exactly where these mats tend to occur, how they're sort of built naturally, and whether that's exactly something that we could replicate. So that's a sign of resilience. Now for my sign of hope. Hope to me comes in the form of this little place. Watch that orange arrow. This is DeVoe Bank. It's off the coast of South Carolina. It didn't exist after a 1978 hurricane. Starting in about 1984, it started to reappear. By 2020, it's about 1 kilometer long by half a kilometer wide. And one of my colleagues, Felicia Sanders, was anchored off off the edge of DeVoe Bank one morning when she saw this. Step out of the way. This is thousands upon thousands of whimbrel taking off that had evidently spent the night on the island. Now, if you know anything about whimbrel, just like those other long-distance migratory shorebirds I told you about, the populations have been declining. And it's estimated that there are about 40,000 of them in the Atlantic flyway. So the fact that right there in that one photo is about 5,000 of those 40,000, and that nobody had any idea they were on DeVoe Bank is something that gives me hope. Felicia had spent years studying brown pelicans out there. She had no idea. If we go back to this map here, those are the two most popular resort islands in South Carolina. We've got Kiowa and Seabrook right there. It's just offshore. Nobody had any idea this phenomenon was happening there. So Felicia helped me recruit a great graduate student, being a handmaker, and then along with Andy Johnson, who's a cinematographer from the Cornell Lab of Ornithology, we endeavored to try to explore more about what's going on at DeVoe Bank. And so what we first set out to do was some nocturnal roost counts to actually quantify how many whimbrel are using the island. And what we found is at the peak of migration, literally half of all known Atlantic flyway whimbrel are coming to spend the night on this one tiny sandbar. So that red line sort of traces how many whimbrel we had cumulatively counted over the course of the evening, and those bars count how many were showing up during a half-hour window. So you can see there right around sunset between 10 and 11 o'clock, or sorry, 8 and 9 o'clock, we had like 7,000 whimbrel just streaming past us. Just really mind-blowing stuff, at least to me. So we've got this one tiny little island supporting half of an entire population. So we knew that we had to get the word out. And one of the things that Cornell is really good at is getting the word out. So they were able to get us a spot in the New York Times. If you can't read that, it says, "Leave this wondrous island to the birds." More importantly, they actually also got us into a lot of the local media in South Carolina. And within a year, Felicia had successfully been able to close all of the beaches on DeVoe Bank to public access, cease nightly Coast Guard flyovers. I had no idea, but apparently the Coast Guard flies the entire US coast each and every night to make sure nobody's out there getting lost. They fly at a low elevation that scares all the birds. up from the roosting areas. So she was able to convince them to fly around DeVoe Bank. She was then able to argue that this kind of protection need to be extended to other South Carolina state-owned beaches. And now South Carolina has actually acknowledged that they will incorporate shorebirds into all future coastal decision-making processes, which, if you know anything about the South Carolina state government, might actually be the biggest feat of all of these. So things actually happen fast. What we're now trying to do is we're tracking, of course, we like tracking, we're tracking whimbrel to see where they go when they leave DeVoe Bank, because they don't all feed on the island during the day. So what Maina has found in her preliminary results, DeVoe is right here. You see them all coming back, and then each day they spread out, and they're spreading out over this massive stretch of South Carolina coast. Some birds are flying over 50 kilometers one way each morning and 50 kilometers back each evening. And so this is telling us is that DeVoe is supporting just this massive group of birds that are moving out over an even more massive area, meaning that we have to really couple our sort of spatial scales for conservation action. DeVoe Bank is only one little but integral piece of the story of protecting birds along the South Carolina coast. So we think that just like with those floating rafts, that potentially if we can figure out how to construct using, say, dredge spoils from the Army Corps of Engineers, how to construct islands just like DeVoe Bank elsewhere, birds may not have to be commuting so far. And the energetics, as they're preparing for another northward flight, as I should have said, this was all during migration, may mean that by not having to fly as far, their costs of migration are much lower than they might otherwise be. So this is our current focus, is how to create more DeVoe banks across the Atlantic coast. So that's what we're doing. What can you all do? Because I'm trying to have an uplifting endpoint here. Well, the first thing I would say is if we learned from Godwits or any of the other shorebirds that we've looked at, is minimizing disturbance is actually a really big thing, and it's hopefully really easy to do. We've also seen that science communication can work. So wherever we have habitats that we think are really integral, making sure that we help others to actually know why they're integral and how they can go about treating them appropriately. Community science databases are huge. eBird, of course, is a great conservation tool, but there are other ones as well. This happens to be the banner from a group called bandedbirds.org. So if you were to see an individually marked shorebird, you can report that combo to this, and it would come back to someone like me who's put my banding database in there and let me know where my birds were seen. And then maybe I would say most importantly, because we here in Pine Valley don't live on the coast, water. Water matters here. Who goes to the East Hampton Meadows after it rains to see what's shown up? Why is that? It's because most of the natural marshland that we may have once had along the Connecticut River is no longer there. But those agricultural wetlands can be huge. And so figuring out how to get water on the landscape at the right moment in time can be really integral for these birds during passage. So with that, thank you all very much. And I also want to just point out, I've got 7 awesome graduate students and some undergrads. And if you want more talks about shorebirds, let me know, and I will poke them. Also, awesome collaborators and some great funding agencies. All right, thank you very much.
Thank you, Nathan. Let's see. So do we have a microphone around for? Oh, here we go. Thank you, Nick. All right. Any questions from the audience here? Oh, I see one.
Thank you. That was very interesting. My question is around In South Carolina, you pointed out that 2 of the most popular resorts are right there. And then you talked a little bit about minimizing disturbance. And how does that work? And have you had any backlash? How do you work with those students to get them? This is a good idea to both their beaches.
Yeah, well, so luckily, the boat bank is a boat right away. So we can sort of intercept people, but that's where I think the communication really becomes integral. So the state is now put in for shorebird stewards who can be sort of present in the area on weekends when people tend to go out boating, to talk to them about hey, here's why you can't be on the island right now. And then working with both of the Kiowa and Seabrook Island have their own conservation boards associated with the resorts. And so working with them on sort of times for different kinds of activities on the beach. So dogs are only allowed during certain hours of the day, during certain parts of the year. But all in all, I would say it really is about non-confrontational communication. It's having people in the right place to sort of intercept things before they go awry, so that it's not like hey, you can't do that. It's more like, hey, let me tell you about the shorebirds. Here's what's going on right here. But yeah, there's always some folks who are like, I don't care. I want to be out there. So pluses and minuses.
Greg, was that signal out very?
I do have a question off of the, yeah.
Okay.
So, yeah. So this is a question that comes from the chat from Sally Crawford. I read that on long nonstop migrations, birds have an adaptive way to sleep. Is this accurate? And if so, how do we know?
You know what? Every time I or somebody else who studies long distance shorebird migration gets asked about sleeping, and every time something winds up in the story about, we think birds might sleep in the air. We don't know. We have no idea. We know that other birds, like frigate birds and swifts, are able to use what's called unihemispheric sleep. But what they do that the shorebirds don't is they soar. So you can soar in one direction with one part of your brain turned off. You can soar in the other direction with the other part of your brain turned off. But shorebirds are flapping the entire time. So we don't yet have any idea whether or not they can sleep. We know that during the Arctic summer, that on the ground, there are the male shorebirds use what are called like micro naps. They're like 1 second sleeps. And they found that the ones that do more of it miss out on the copulations with females. So there's strong selection to not sleep. But then if you look at how long those males live, there's some trade-offs there. But yeah, what they do in the air, we unfortunately don't have any idea.
Thank you. Fantastic presentation. I'm curious about the life cycle differences between the bar-tailed and Hudsonian Godwits. It seems like the bar-tailed Godwit makes its most exposed overwater journey in the fall, coming back to its wintering ground, and then makes you might disagree with me, but maybe a less risky but longer passage around the rim of the Pacific and in the spring. And it seems like the Hudsonian does it the other way around. Is there any speculation as to why?
What do you think?
I don't know. I'm wondering if there's some lifestyle difference that makes it more sensible for one bird to take more risks in the fall and the other to take them in the spring, or is it just random chance?
Neither. Wind. Yeah. So the bar-tailed Godwits, when they're taking off in the fall from Alaska, are able to make use of these huge storms that pass. They come out of the Bering Sea and flow into the Gulf of Alaska. Great tailwinds that they're able to ride almost all the way to Hawaii, where they then have to find some different wind tracks, and they have some doldrums there, and then they make they hopefully find another tailwind sort of south of Hawaii and make the rest of the way to New Zealand. Those same winds would not help them going back that same route in the spring. So they take tailwinds from New Zealand, head to China, and then they do a less arduous flight there from China back to Alaska that often does fight some winds, but is going over shoreline that they could potentially stop on. So it's a wind-driven thing for them, and it's likewise a wind-driven thing for Hudsonian Godwits in the spring. If anybody's heard of the Humboldt current, it's this really strong oceanic current that runs up much of the Pacific coast of South America. Really continuous south to north winds along that route. So Hudsonian Godwits are taking off from Chiloé with a wind that they can ride basically all the way to the Galapagos Islands. Then they hit some doldrums, have to really fly on their own, and then hope to hit some more tailwinds as they cross Mexico and into the Gulf of Mexico. So that's the answer. Is wind.
Thank you.
I'm very interested in these highly specific sites of rest for both the Godwits in Chiloé and the Wimbles on DeVoe Island. I'm wondering, I think more specifically for DeVoe Island, since it's such a tiny little sand bank. Is it also a haven for other bird species as well? Is it more so for the Wimbles than any other species? Like, what's sort of the makeup?
Yeah, so it's a great place for shorebirds in general in spring. Lots of willet, lots of short-billed dowitchers, dunlin. See what else? Even some red knots that are out there. But it is proportionally most important for Wimbrel, and that we haven't tested this, but we think it has to do with predation risk. So Wimbrel are heavier, takes them longer to get off the ground, and so they need to be in a place that is less likely to be impacted by especially ground-based mammalian predators. So it's just far enough offshore that it's less likely, although we find a mink out there basically every year, less likely to have ground-based predators. So those other smaller shorebirds can and sometimes do roost on either closer inshore islands or even sort of mainland habitats, because they can get off the ground more quickly and hopefully get away from those predators. So that's part of the issue, though, in us trying to find a way to place artificial islands, is making sure, right, that it's in the right place, that mink, raccoons, et cetera, are not just going to overrun it.
I have a feeling we're gonna be hearing about some very similar stuff from Joan Walsh about the roseate tern.
I bet so. Yep.
No, that's not it. All right, I had a question or two. Others taking a pause. I will. I have to remember which question I wanted to ask. So, you had talked about the fact that the Hudsonian Godwits never take a year off from breeding, which I think the only species I can think of is common loon, where I've seen like birds that just decide to not migrate to the breeding grounds, spend the whole breeding season where they wintered. So, I guess how common is it for birds to be either all breeding or to take these years off? And how does body condition play in?
Yeah.
It seems like the bad conditioned birds were the ones more likely to spend the summer where they wintered.
Yeah, so it does strongly interact with how large the species is and how long it's hoping to live. But you see skipped breeding more so in things like geese and cranes, albatrosses. A lot of albatrosses have it's not even a skipping, they have like a 2-year cycle. So yeah, the bigger the bird, I would say the more likely they are to skip a breeding bout. There are some shorebirds, Wimbrel and bristlepied curlews being two that I can think of, where we do know that they're at skipping. I know that there are some bar-tailed godwits that are on New Zealand year round. I don't know what the makeup, if those are all just juveniles, because that's the other thing is large-bodied birds, especially large-bodied shorebirds, will have what's called delayed maturation, where they might not breed for the first 2 or 3 years.
You don't have anything like with, say, with sandhill cranes, where you have the migratory populations, but then you have, say, the Florida population that's become non-migratory and breeds like where they're, what presumably was their wintering spot. in the
Yeah.
past, and are there any shorebirds that do that, or are the shorebirds all, you know, if they're gonna breed, they migrate?
Well, there are things like killdeer and some of the coastal plovers. I couldn't tell you for sure that wasn't the route by which they had sort of more southerly breeding populations rise, but not in any of the scolopacid, the sandpiper shorebirds. Yeah.
I have a question, and that's, I was lucky enough to go to Malta a few years ago, which is a spot in the Mediterranean where a lot of things funnel through.
Yeah.
Unfortunately, the laws and the practices in Malta do not favor survival of shorebirds and other migratory birds. Have you run into similar international political situations in looking at these flyways through South America and Central America?
Yeah, so the Caribbean and north coast of South America, particularly Suriname and Guyana and French Guiana, has had a long history of shorebird hunting. So there was, 15 years ago or so, when the first whimbrel actually that was tracked with a satellite tag, unfortunately wound up on the island of Guadeloupe in a hunter's bag. So there have been really extensive efforts over the past 2 decades to try to, not necessarily take away sort of traditional practices, but bag limits in place and make it a more sustainable thing. At least on the Caribbean islands, tends to be more hunting tourism than it is necessarily, any sort of traditional practice. But on Suriname, it's definitely a more traditional thing.
And are they looking for meat or is it skins?
Well, certainly in the traditional practices, right? That's more meat based. What the hunting tourism is about on Guadeloupe and Martinique and some of those places, I couldn't tell you personally, but I do know from having lived in Europe that France, bird hunting is an important part of some folks' sort of culture there, and so it's been a real sort of battle in France as well for curlews and black-tailed godwits to try to curb some of the hunting practices.
I have another one. So anybody who knows me knows I'm into insects and invertebrates, maybe even more so than into birds. So when you talked about being in Alaska, that you were all in it for the ticks, I was at first meant like eight-legged things, but so the graph you showed of that month where the invertebrates and their diet peak, what, everybody thinks of tundra and mosquitoes, and what are the invertebrates that godwits are dependent on?
They're fairly generalist. So there are things like, the tupulid and chironomid larvae. It's not the ones that are flying. Those are 2 kinds of flies.
Crane flies and midges.
Yeah. And then spiders are a huge proportion of the Arctic invertebrate sort of fauna. Yeah. And so I would say those are the 3 sort of biggest ones, but that's just sort of a proportion of abundance to begin with. Our data doesn't suggest that they're necessarily honing in on any one sort of group out of proportion. They're just general abundance.
Okay. We have any other questions from? Oh, yeah.
You started by showing us some unbelievable metabolic changes that are occurring in these birds before they go. I just wonder what the trigger is. Is it just photoperiod?
Don't know. Yeah. If you want to come do a PhD, please do. I'll make room. Yeah, I don't know.
You got this, you're ready for grad school.
I'm gonna guess it's not photo period because we have individuals that are failing at breeding at sort of different points within the summer, and it's the Arctic, and so there's not huge changes right during that core summer period in photo period. And then they're not hanging around on the breeding grounds, they're getting out of there. So I don't know if it's more of a, like I'm done reproducing, and so this is the next thing that happens, or what. Yeah.
Okay, any more, or Greg, any others on Zoom?
No, we're good.
All right, that's all for questions. One more, thanks for.
Hope to see you all up early.
Thank you.
We'll see you all back here next month. Hey, that was.